Today's AI and cybersecurity briefing starts with a practical warning for builders. If your application accepts user-supplied JSON schemas and sends them into llama.cpp grammar conversion, treat that path like an exposed parser, not a harmless utility. We will also cover an OpenShift Router issue that can affect client certificate identity headers, a KubeVirt CDI permission problem that can expose persistent volume claim data, and a Linux kernel local privilege escalation tracked by Red Hat. The main takeaway is simple: patch where fixes are available, reduce untrusted input, audit RBAC, and preserve logs before cleanup. Story 1 is the AI angle. NVD lists CVE-2026-17500 and CVE-2026-17501 for ggml org llama.cpp. The affected area is JSON schema to grammar conversion, which many LLM applications use to constrain model output, enforce structured responses, or validate tool calls. CVE-2026-17500 involves the _visit_ pattern handling in common/JSON schema to grammar.cpp and can lead to a null pointer dereference. CVE-2026-17501 involves the JSON schema to GBNF transformation path and can lead to resource allocation impact. The NVD entries describe remote attack reachability, no required privileges, no user interaction, and availability impact. NVD's data available during production included CVSS version 3.1 medium scoring, and version 4 medium context has also been reflected in the metadata update. The important operational point is not the exact decimal score. The important point is that a component often embedded inside AI gateways can be stressed by input that may arrive from outside your trust boundary. Why does that matter for LLM teams? Structured output feels like an application feature, but under the hood it can involve parsing a schema, converting it to a grammar, allocating memory, and running code paths that may not have been designed as a public internet parsing service. If a SaaS product lets tenants upload schemas, if a developer tool exposes schema conversion through an API, or if an AI agent framework accepts partner-supplied tool definitions and converts them automatically, the converter becomes part of the attack surface. Even when the immediate impact is availability rather than code execution, repeated crashes can create downtime, hide other security signals, or trigger emergency rollbacks that introduce new risk. The defensive playbook is straightforward. First, monitor the llama.cpp issue and pull request references linked by NVD, then deploy fixed builds when maintainers publish and your packages update. Second, do not process arbitrary internet or tenant schemas in a privileged long-lived process. Put conversion jobs in isolated workers with low privileges. Third, enforce time limits, memory limits, maximum schema size, and maximum nesting depth. Fourth, rate limit conversion endpoints and add telemetry for crashes, repeated failures, and unusually large or complex schemas. Fifth, document where schema conversion happens in your AI stack, because it may be hidden inside a library or an agent gateway rather than in the obvious application code. Story 2 moves to Cloud Edge infrastructure. CVE 2026-17527 affects the Red Hat OpenShift Router. The reported condition involves routes with insecure edge termination policy set to allow. In that configuration, the HTTP frontend may not remove XSSL client headers from incoming requests. Backends that trust those headers as proof of mutual TLS client identity can be fooled by spoofed header values if the traffic path allows them through. This is a classic trust boundary problem. Security information that should be created by a trusted edge can become attacker-controlled input if the edge does not sanitize it. For OpenShift operators, the first action is to identify affected routes and applications that consume XSSL client-style headers. Do not assume every backend is safe just because TLS terminates somewhere in the platform. If an application uses forwarded certificate headers for authentication, authorization, account mapping, or audit records, validate that those headers are stripped from untrusted requests and only reintroduced by trusted infrastructure. Apply the referenced Red Hat errata for affected deployments. Also review access logs for unexpected client certificate header values, especially on applications that mix public routes with internal identity assumptions. Story 3 is KubeVirt CDI. CVE 2026-17527 concerns containerized data importer and an aggregated CDI.KubeVirt IOView cluster role. The advisory text says the role includes create permissions on a data volume source subresource. In the reported scenario, a user or service account with view plus ordinary write access to a namespace they control may be able to clone persistent volume claim contents from another namespace into their own namespace. NVD lists this as high severity. The practical concern is data exposure across Kubernetes namespace boundaries, especially in clusters where many teams, tenants, or automation systems share the same virtualization platform. For KubeVirt teams, audit cluster role bindings and role bindings that grant broad view access. Look for service accounts that combine read-style permissions across namespaces with write permissions in a controlled namespace. Review recent data volume clone activity for unusual source and destination namespace pairs. If your environment stores VM disks, build artifacts, secrets, or tenant data in persistent volumes, treat unexpected clone capability as a data loss risk, not only as a Kubernetes configuration bug. Update through vendor packages when available and consider temporary RBAC tightening where business workflows allow it. Story 4 is CVE 2026-17523, a Red Hat tracked Linux kernel local privilege escalation with a high CVSS score and an upstream Linux commit reference listed by NVD. Local privilege escalation bugs matter because modern incidents often begin with a low privilege foothold, a compromised developer account, a vulnerable web service account, a malicious package in a build runner, or a container escape chain that starts with limited host access. If that low privilege foothold can become root, the blast radius changes. Prioritize multi-tenant servers, developer workstations, Kubernetes worker nodes, CI runners, and GPU inference machines where many jobs or users share infrastructure. Patch through supported channels and reboot into the fixed kernel. Installing an updated package without rebooting does not remove the running vulnerable kernel. Today's pattern is bigger than any single CVE. AI schema converters, edge routers, storage importers, and kernels are all trust boundaries. The safest teams inventory where those boundaries exist, limit what crosses them, and patch quickly when trusted sources publish fixes. For builders, the AI lesson is to stop thinking of LLM helper code as low-risk glue. Parsers, converters, prompt tools, file handlers, and agent connectors all process untrusted data. Give them resource limits and isolation before an outage forces the issue. For business leaders, the message is to fund boring controls, dependency tracking, RBAC reviews, log retention, and fast patch windows. Those controls decide whether a medium availability bug becomes a contained ticket or a customer visible incident. To close, here is the checklist. Track the llama.cpp fix and restrict untrusted schema conversion. Add worker isolation, timeouts, memory caps, rate limits, and crash monitoring. For OpenShift, sanitize client identity headers and patch routers. For KubeVirt, audit view grants, namespace write access, and data volume clone events. For Linux hosts, patch and reboot affected kernels, starting with shared infrastructure and AI compute nodes. All source URLs are in the description, and this briefing is defensive only, no exploit code, payloads, or attack walkthroughs are included.